The summary of nucleus. In this topic, normal. In this topic, we are talking about nucleus and its behavior. First, we know that nucleus is present in an atom, and this nucleus made up of two type of particle. One is proton, second is neutron. Each particle is known as nucleus. Okay, so whether it is proton or neutron is known as nucleon. Okay. We also know the basic detail about the nucleus. Its size is very small, like 10 raised to power minus 15 meter, or we can say 1 femtometer. Very, very small. Correct. And when we consider the total atom, example any X atom, Z represent the proton number and A represent the proton and neutron both. That's why proton number is equal to Z, neutron number is equal to A minus Z, and A is equal to proton plus neutron. Okay. If you say isotope, it means Z is same. If you take isobar, then atomic mass is same. And if you take isoton, it means number of neutron means A minus Z is same. Okay. If you compare the radius, then radius of nucleus radius R depend upon the atomic mass under 1 by 3, correct? Under cube. And that's why this is related with the radius. If you take R cube, it will directly depend upon A. Volume will also depend upon A. But interesting part is if you take density, then density is equal to mass by volume. Mass is equal to A into given mass of the nucleus, and volume will be equal to 4 by 3 pi r naught cube and A cancel. So density is constant for all the nucleus. It does not depend upon the mass. Volume depend upon the atomic mass. R depend upon the mass, but density is constant. Okay. When we see different type of force, then there are three force. One is gravitational force. Second is electrostatic force, and third is the nuclear force. Out of these three forces, we know nuclear force is very strong. Strong nuclear force is very, very strong. And because here we are talking about the nucleus, so we need to talk about the nuclear force. One of the strongest act between the nucleon. A force that act only for the short range, because if you increase size, then it this force will be negligible. It does not depend upon the charge. Doesn't matter which charge is present on the nucleon, there will be same nature of the force, and this force is not central. Do not act along the line. How electrostatic and gravitational force act. And last one more point key. This is spin dependent. It means if both the nucleon have same spin, then there will be strong force. Opposite spin, then there will be less force. Correct? When we explain this, then Einstein equation E is equal to mc square is very popular, which say that energy directly depend upon the mass. More mass can produce more energy. It means if your mass is changing, your energy will also change. This is known as mass defect. Why we talk about mass defect? Because if you take total number of proton and proton mass, how to calculate proton mass? Total number of proton and mass. Neutron mass, same way. Total number of neutron, A minus Z. and mass of the neutron. Okay. So when you calculate the mass defect, you see total nucleus mass and its constituent mass is not same. Actually, there is a difference. And how to calculate difference? Add all the constituent mass and then U minus the mass of the nucleus. And it is different. There is some mass defect. Okay. And in this case of mass defect, you will see you always need energy to break the nucleus. And for this, we have a specific term binding energy. Binding energy tell us that we have to break the bond between the two nucleons. The energy required in this is binding energy and how much energy we need for one nucleon. How to calculate? Calculate total binding energy and then divide by the atomic mass. You will get binding energy per nucleon. What is the significance of this binding energy per nucleon? Stability. If there is more binding energy, then stability will be high. Why so? Because if you need more energy to break anything, it means this material is extremely strong. Okay. So every nucleus want to become the stable. How? If you have this small nucleus, then it will have binding energy per nucleon very low, and then it will try to fuse. If you have large nucleus, then again binding energy per nucleon is very low, then it will break. Fission will happen in this case. Okay. And based on this, you study about the two type of reaction. First is nuclear fission, which say that one big nucleus will break down, which have usually mass more than 230, and form the small nucleus. Okay, bigger convert into the smaller. How? Example, if you have uranium 235, it react with a neutron. What will happen? It will convert into the smaller atom and there will be release of the energy. But interesting part is some neutron is produced in this situation. Such neutron are known as secondary neutron. Such neutron are known as secondary neutron. Okay. Next, we want to calculate how many neutron is lost in a reaction and how many neutron is produced. This is explained by the reproductive factor K. How many neutron is produced divided by how many neutron are lost in the reaction. If K value is 1, then you will say this is a controlled reaction. And in this controlled reaction, it is critical and you can use this for the nuclear reactor. It is really, really good. Second, if K value it is supercritical, supercritical means it is dangerous. And when it is dangerous, then it can be used in the atom bomb because too much energy is produced continuously. If it is less than 1, then it is subcritical means not enough amount is present. If not enough amount, ultimately it will stop. Okay. Based on this nuclear uh, fission, we can say for the nuclear reactor, your reproduction factor should be 1. So what is a nuclear reactor? A system where you use uh, radioactive material to produce energy, to produce electricity. So nuclear reactor produce electricity. What do we use in this nuclear reaction? Of course, nuclear fuel. And this nuclear fuel made up of either uranium 235 or plutonium 239. Plutonium is best. Then you need moderator to speed down or slow down the speed of the neutron. And for this, you use heavy water. Heavy water D2O will slow down the speed of the neutron. Third, you have control rod to manage the chain reaction. Is it uncontrolled or controlled manner? So boron and cadmium form this control rod. And last, coolant. If too much heat is produced to control this, we have coolant. Usually we have water at high pressure. In this situation, we have water at high pressure in case of nuclear reactor. Then last reaction is nuclear fusion. When two or more small nuclei combine and they produce a big nucleus. Example, hydrogen have very small nucleus. When hydrogen combine, it will produce helium, a bigger nucleus with two positron and lot of energy, about 26 mega electron volt. If you see in case of uranium, here around 200 mega electron volt energy is produced. Here around 26 mega electron volt energy. So of course you see कि in one nuclear fission more energy is produced. But per nucleon, because if you compare here, it was with 200 mega electron volt. Here it is 26. So of course, in nuclear fission, more energy. But if you take binding energy per nucleon, then fusion produce more energy compared to the fission. For this nuclear fusion, proton will repel each other. So you have to overcome this force. That's why you need very high temperature in this situation, as well as you need very high pressure so particle can interact with each other easily. They collide and form the product, fusion product. Tell me guys, any doubts?
No, sir.
Was it?
Yes.
Yeah, solve this question. Energy required to break one bond in DNA is this. What will be the value in electron volt? What will be the value in case of electron volt? You know, 1 electron volt is equal to 1.6 into 10 raised to power minus 19 joule. Correct? So can we say 1 joule will be equal to 1 by 1.6 into 10 raised to power minus 19 electron volt. So 10 raised to power minus 20 joule will be 10 raised to power minus 20 divided by 1.6 into 10 raised to power minus 19. So if you cut, it will be 10 raised to power minus 1. Correct? So if you take one more zero, then it will be 10 raised to power minus 2, approximately 6. So can we say 0.06? See, any doubt? Just unit conversion, isn't it? This is given in joule, you have to calculate in the electron volt, and you need to know this. Any doubt, guys?
No, sir. No, sir.
Chandana, next question. Energy equivalent of 0.5 gram of a substance is. Is this correct? Do you have this option? Yes. Any doubt? E is equal to mc square. Mass value is given in grams. You will convert into kilogram. That's why I divided by 1000. And then c square value. Sarah, how does the binding energy per nucleon vary with the increase in the nucleon number.
The first increases
Example,
and then decreases.
yes, from 1 to 56 it will increase and then it will decrease. 56 is iron. So from hydrogen to 56 iron it will increase, then it will decrease. Sania, mass of lithium is this unit less than the sum of all its constituents. What is the binding energy per nucleon of this? So what is delta M? 0.042, correct? If you calculate in the form of delta M total, because it is given in the unit U, correct? And I will add this in notes. One one AMU will produce 931.5 mega electron volt by C square. Okay. So if you know this value, now you can calculate. If this is the value, how to calculate delta M? 0.0422 into 10 is 931.5. Okay. If you do calculation, it will be around 40. And how to do? You know, this is the answer because this is given divided by C square. And you know your energy is equal to mc square. So it is around 40 by c square into c square. Done. So it's easy to do. What is given near to the 40? Binding energy per nucleon in this case 40 divided by 7. This one, right? No, 40 divided by 7. So around 5.6. Give me 1 minute, guys. So tell me, guys, any doubt or should I explain this again?
So could you explain it again?
Yeah, sure. So when we are calculating such question, you need to understand what is the value of 1 unit. Here it is 931.5 by c square. That's why I'll do one thing. I will write it separately. 1 unit value is 935 by c square in mega electron volt. This is 1 unit value. Here, what was the mass given? 0.042. That was the difference in the mass. Mass defect 0.042 unit. Correct. So what is the total mass defect? 0.042 multiplied by 931.5. For easy calculation, you can take 930 or 931 also by C. Now you have to calculate energy, which is equal to delta m c square. Delta m value is 0.042, 931.5 by c square multiplied by c square. This will be cancelled. You have to do direct calculation. This will be the total binding energy. Once you get total binding energy, then binding energy per nucleon will be total energy is around 40 divided by what? Divided by will be 7. Then it will be around 6, approximately 6. Even if you don't do this, I'll tell you the easiest way to calculate this. Here you have approximately 900. And if you take 0.05, let's take half. So it will be around 45, around 45. I'm not telling exact value. And if you divide 45 by 7, your answer should be close to 6. Now look at the options. which option is close to 6. Done. Sarah, any doubt?
No, sir.
Next, Sania. Mass is this mass of the proton, neutron is
लेकिन
denoted.
मेरा इसका आंसर अलग आ रहा है.
कैसे? बताओ क्या दिक्कत आ रही? कैलकुलेशन किया था?
हाँ सर.
अब देखो, if you do calculation, delta m is equal to 0.042. Let's take like 0.04 by 100. Take it approximately 900, around 36 in the easiest way. Though it will be greater, but around 36.
हाँ सर.
Correct. Same will be the energy, and binding energy per nucleon will be 36 divided by 7. It will be more than 5 because you already had 931 also. What is the answer? More than 5. Only one. Tell me. You made a mistake in calculation.
Yes sir, got it.
Do 21st question. See, same thing is given. 1 unit is equal to 931.5 mega electron volt divided by c square and binding energy. So what will be the total mass? What will be the nucleus mass? In this situation, how will you calculate this? You know, binding energy is equal to delta m into c square. Delta m value will be binding energy by c square. So this by c square is equal to what is how to calculate delta m? This
Z
whole thing is a
delta.
constituent mass.
Yes sir.
I'm saying any constituent mass x minus nucleus mass. Now you are calculating for the nucleus mass. How to calculate x minus binding energy per nucleon by c square? Any doubt?
No sir.
Answer will be C. Tara, next question. What will be the binding energy? This is constituent mass, proton and neutron. This is nucleus mass. Difference between them is delta m multiplied by c square. Any doubt, Sarah?
Yes, sir. I didn't understand it.
You didn't understand. Should I explain this again?
Yes, sir. Yes.
Yeah. So you know in this situation, binding energy is equal to delta m c square. What is delta m value? Mass of the constituent minus mass of the nucleus. Mass of the constituent is mass of the proton. This is mass of proton plus mass of the neutron. This is total constituent mass minus mass of the nucleus. This is delta m value. The whole thing multiplied by c square. Tell me any doubt? Delta m into c square. Delta m value is constituent mass minus nucleus mass. Understood?
Yes, sir.
Chandana 23rd. Fission of the nuclei is possible because of the binding energy nucleon in this case. if you increase mass in case of fission, it means already you have big molecule. That's why fission is possible. If you increase mass, then binding energy per nucleon will decrease. Understood? Binding energy per nucleon will decrease. Done? Okay. Chandana, any doubt?
Sir,
Yeah, any doubt?
सर
sir,
लेकिन बाइंडिंग एनर्जी पर न्यूक्लियन लो मास नंबर्स के लिए भी तो डिक्रीज होता है.
लो मास नंबर के लिए भी डिक्रीज होता है, लेकिन फ्यूजन के केस में अगर हम बात कर रहे हैं तो इंक्रीज होगा ना. Already you have heavy molecule like uranium 235. Let's take this. Now, if you further increase mass, you take plutonium 239, then you will see कि here binding energy per nucleon will decrease, right?
यस सर.
It means if you decrease from this side, like mass, you take 192, then binding energy per nucleon will increase. Understood?
यस सर.
Huh. Sania, next 24. Mass of the proton is this, and neutron is this. What is the binding energy of helium? Helium mass is this. Correct? So first you will calculate delta M here in units. Right? First you will calculate delta M. Whatever you will calculate and whatever will be your answer, delta M value, you will multiply that number with 931.5. But for easy calculation, keep it near 900 so it will be easy to calculate. Understood? You will get the answer. Any doubt?
नो सर.
Sarah, 25th. Which of the following is suitable for the fusion process?
sir, light nuclei.
Light nuclei, done. Heavy nuclei, fission. Chandana, 26th. And neutron and dead proton. Why? I told you constituent have
So because of the mass defect.
yes, because of the mass rate, constituent have more mass compared to the nucleus mass. Give me a minute. Hello. ठीक है बुआ. Understood? Constituent have more mass compared to the nucleus mass, and because of that, you get the mass defect. So when you calculate the mass defect, it is the constituent mass, correct? Like this neutron minus mass of the nucleus. Why? Because constituent mass is more. This is high, correct? So can we say this is high compared to the nucleus? So Sani, 27. Because when fission happen, example uranium 235 in presence of neutron break down into krypton and barium. It also produce lot of energy, 200 megawatt. Some mass convert into the energy. Some mass convert into the energy. Uh, Sarah, binding energy per nucleon is maximum in which element?
So maximum in iron.
Iron. Chandana, energy equivalent of one atomic mass unit is equal to
931
931 mega electron volt. Energy, remember, not mass, energy. Energy. Sania, 30th question. Average binding energy per nucleon inside the atomic nucleus is about
8 mega electron volt.
around 8 mega electron volt. I told you most of the element have binding energy per nucleon near 8 mega electron volt. Sarah, you have background voice. Next, Sarah, question. If the nuclear force between the two proton, two neutron, and two proton neutron is this, what will be the force value? Doesn't matter whether it is proton proton or proton neutron or neutron neutron, force will be same. Nuclear force will be same. Any doubt, Sarah?
No, sir.
And next, Sandana, true about the nuclear forces.
So they are short range force.
Yes, they are short range force. We discussed this point. Radioactivity we don't have in syllabus, and with this we did all these questions. Whatever were left, you know, atomic mass. They can ask number of Z value, atomic mass, neutron, electron, right? And percentage. In size of nucleus, there is rule like R directly depend upon A by 3 atomic mass. Density independent, doesn't matter. Whatever is the value. Volume directly depend upon A. These three rules. Tell me guys, did we leave anything? Anything we left? Nuclear energy we have in our syllabus. So, Sania, you have uranium this isotope bombarded with one
Sir,
neutron,
your
it
voice
generates
was
krypton.
cracking a little, so can you please repeat what you just said?
Yeah. So what is the answer of 84th question? How to do this? Check the relation of the in case
Sir,
of
option
uranium.
A.
Yeah. In case of uranium, Z value is 92. This is 36. Remaining is 56. Done. Understood? Remaining is 36. Next, Sarah. A certain mass of hydrogen is changed to helium, nuclear fusion. Mass defect is this energy. Energy liberated per unit if 1 unit is value this.
So 26.7 mega.
26.7 will be the value. But remember, they are asking per unit. So you will divide by 4 for helium. Correct? You will divide by 4. If you multiply, value will be 26.7. We already did. Then Divide by 4 per nucleon. This na per unit means per nucleon. Chandana, power obtained from nuclear reactor using this is this. Mass decay per hour is. You have power and you know power is equal to energy by time. Correct? You have time also. And if you want to calculate energy is equal to power into time, energy is also equal to delta mc square. Correct? So you have to calculate delta m, power into time divided by c square. Yes or no?
Yes, sir.
Then Sania, 87th question. Fusion reaction takes place at high temperature because I told this in class. Because you need high kinetic energy so it can overcome the Coulomb repulsion. Correct? It can overcome the Coulomb repulsion. Sarah, binding energy per nucleon for deuterium and helium is this and this. When two deuterium nuclei fuse and form the helium, how much energy will release?
Sir, option A.
Option
A, sir.
very good. So remember per nucleon. Per nucleon. For helium, per nucleon is 7, and you know there are 4 nucleon in helium. So 28. In case of deuterium, what is the number of nucleon? 2. In case of helium, what is the deuterium, what is the number of nucleon? 2. Correct? If you have number of nucleon 2 divide by the 1.1, it will be 2.2. And you have 2 deuterium, so multiply by 2, 4.4. 28, 4.4 difference is this. Anybody have doubt? Chandana, binding energy of deuterium is this. Array, same question. If to deuterium fuse this, what will be the answer? Now you can calculate this. 56 minus 8.8. Wait. Binding energy, not binding energy per nucleon. This is given binding energy. If binding energy is given for helium, it is 28. And for 2 deuterium, 4.4. Same question, same answer. In last question, there was binding energy per nucleon. Here we have total energy. Sania, any fission process mass of the fission product by mass of the parent nucleus is
equal to 1.
less than 1. Fission. Breakdown. Na?
Yes.
Fusion means more than 1. They fuse, two molecule fuse. Here break.
Sir, but
Correct?
fission is controlled reaction.
Yeah, fission is a controlled reaction.
Fission nuclear reactor.
But you see mass of the fission product because some of the energy will be released, right? Example,
Yes,
you
sir.
have 100 joule energy in reactant, parent nuclei. Now product will form 90 joule energy and some energy is released. Now if you see product is 90 by reactant 100, then it is less than 1. Make sense?
Yes, sir.
Sarah, next question. In a nuclear fusion process, mass of the this and mass of the resultant nucleus is this. Then Constituent form always have high mass compared to the nucleus mass. We did the same thing, delta M. Correct, Sarah? Always have more mass than mass of the nucleus. Any doubt? Chandana, solar energy is mainly due to caused by burning of the hydrogen in oxygen, fission of uranium, fusion of the proton during the synthesis of heavier element, or gravitational contraction. You know, in sun, hydrogen, when combined with each other, they form helium, right? So fusion of proton means hydrogen and form heavier element, helium. Sania, nuclear fission is best
Yes.
explained by liquid drop theory. So you can add liquid drop theory explained nuclear fission. There are many concepts uh, which are used to explain like nuclear fission, nuclear fusion, and liquid drop theory is one of the popular concepts which explain Raghu, remember this. Where we use like how what you can say stability and binding energy is related because it's like nucleus is like water drop. It's incompressible, have very high surface tension, strong nucleus, all this stuff. Mm. Sarah, moderator, heavy water. Sarah is
Yes, sir.
next. Chandana, uranium is this fission rate of uranium filled reactor operator at a power of this is. So what will be the fission rate, breakdown rate? So fission rate will be equal to total power by energy per fission because fission rate, that's how you calculate. Power is 5 and this is 200 mega electron volt. Na? So 1.6 into 10 raised to power minus 90. You can calculate. Understood? So again, you can add what is, what is the fission rate, breakdown rate. So how to calculate fission rate? What is the total power divided by what is the energy per fission? Energy is one breakdown, remember. Then you can calculate total per unit time. And last, Sania, solar energy is due to,
Fusion reaction.
in case of sun, fusion reaction. So tell me, guys, we did each and every question, which whatever was possible from this chapter, and we already did everything from your atom. So this chapter is done. We did summary, we did all the questions, and finally we can say